So welcome, my name is Vincent Nando. Today we are going to discuss the solutions to some few questions on Fourier series. So I hope this lecture will make you to have a more or a better understanding of how to solve such problems. So the first the question that we want to solve is this one here. To expand the function f of x equals to the absolute value of x for values of x lying from minus pi to pi in Fourier series, and hence to use our solution to find the value of this series 1 plus 1 over 3 squared plus 1 over 7 squared plus 1 over 9 squared. So if you are able to know whether the function is positive or the function is even or odd, then you can actually do the half range expansion. But if you are not able to tell whether the function is even or odd, you just use the general Fourier series formula. But for this one, absolute value function, it should be clear to everyone that if you are to sketch this function in the interval given, then we'll get this. So this minus pi, and then this is positive pi. And we know that so this function is an even function. So therefore this will be 0. So therefore to expand from minus pi to pi, knowing that the function is even, then get the same thing as getting the Fourier series f of x given by a naught plus summation an cosine of nx, and then n running from 1 to infinity, because this function is even. And we know if the function is even, then a naught is given by 2 over pi, 0 to pi. So for this, we just pick this positive. Remember, this function, this is the same as y equals to x. This limb is the same as y equals to minus x. So just pick this, the one that is positive. So 0 to this one, then the function f of x, and then dx, while an is 2 over pi, integral from 0 to pi f of x, and then cosine nx dx. So in this, if we take this positive positive piece that defines this function, so remember that this f of x equals to this one is even, and the function f of x is the same as x for x greater than or equals to 0. So we are just going to pick this value which defines the positive part. So therefore, where the f of x will put just x for this given piece. So a naught will be given by so a naught will be given by 2 over pi, integral from 0 to pi of the function is x, then dx. When you work out the integration, you get 2 over pi, and then this is x squared over 2, 0 to pi, and putting in the limits, you'll have 2 over pi, and then times pi squared over 2, for this lower limit will be 0, or you simplify, you get pi. And then an will be 2 over pi, integral from 0 to pi, and then x cosine nx dx. This will give you minus 2 over n pi, integral from 0 to pi sine nx dx. So remember, we are using the integration by parts, and when you put in the limit, then u times v is 0. So this reduces to positive 2 over pi n squared into cosine of nx 0 to pi, which gives you 2 over pi n squared into cosine of n pi minus 1. So this would be the same as 2 over pi n squared into minus 1 power n minus 1. So remember cosine, this is how you're obtaining this value, that cosine of when n is 1 pi is negative 1. When n is 2, cos of 2 pi is positive 1. Cos of 3 pi is negative 1. Cos of 4 pi is positive 1. Cos of 5 pi is negative 1. So these things are, so when n is odd, we get negative 1. N is even, we get positive 1. So that's why we have cosine of n pi has two values, negative 1 when n is odd, and positive 1 when n is even. So what can put together all these two solutions is simply just saying negative 1 raised power n. So that's why we are writing cos n pi as this one here. And then cos of 0 we know is 1. So that's what we have this. So this is our an. I remember the reason why we are not writing here this other part here. Remember, this was integration by parts, so that u is taken to be x, so which means du is dx, and then v, dv is given by cos nx dx. So when you integrate this one, you get v equals to sine nx over n. So u times v will give you x sine nx over n. When you put in the limits from 0 to pi. So when you put pi for x here, so sine of multiples of pi will give you 0. Because sine of 180 pi means 180 degrees, so sine of 180 is 0. So multiples of 180 or sine of those angles will still be 0. So therefore, the upper limit gives you 0, minus lower limit. When you put 0, sine of 0 is 0, and even 0 times any value is 0, so minus 0. So that's why we didn't bother to write here the u, v, and putting in the limits, because we know the answer is 0. We wrote just this as a part for integral of v du. So therefore now, therefore the series, when we say an equals to 2 over pi n squared into minus 1 power n minus 1, then this have two solutions. When n is an odd number, then it means that this part will be negative 1. So negative 1 minus 1 is minus 2. Minus 2 times this one gives us minus 4 over pi n squared. So this will be minus 4 pi n squared for n given as odd number. And then when n is even, so this will be positive 1 minus 1 is 0. So 0 times this factor gives us 0. So this is 0 when n is even number. So therefore now, because we are not interested in getting the zero function, so we pick this part that has a non-zero value for odd numbers. So therefore we say, hence the Fourier series for f of x given by absolute value of x in the interval minus pi to pi is given by absolute value of x, which the function is a. Remember, the formula for Fourier series is given by, yes, as a reminder, Fourier series is given by a naught over 2 then plus summation n from 1 to infinity an cosine n. So this one we just stop here because we have already defined that the function is even. So this is what we have. So we have absolute value of x is given by a naught. We go to the a naught to be pi, so pi over 2, and then plus summation n from 1 to infinity, and then the value of n, which is giving us non-zero value, is given by minus 4 over pi n squared. So minus 4 over pi n squared, then cosine of n x. But this can be written as pi over 2 minus 4 over pi. So I factor out this number that doesn't, this part that doesn't involve n, and then summation n from 1 to infinity. So remember, this one is n is an odd number. This one, we define this. So we have cosine n x over n squared, and remember n is odd. So you can write this one in expanded form as so the first, when n is 1, that's the odd number, the first odd number we pick, we have cosine of x. Then next odd number is 3, so it will be now plus cosine 3x over 3 squared. Next odd number is 5, so cosine 5x over 5 squared. Next odd number is 7, so cosine 7x over 7 squared, and then plus other terms of the same pattern. So that's the Fourier series of the function given. Now the other part was to find the value of this pattern here. So remember, this this is over 2 naught. So f of x a naught over 2 naught, yes, a naught. This is the formula. So we have a naught over 2 naught, yes, a naught. So we have to find the value of this series. So for us to be able to get that answer, so we ask ourselves, how can we make this trigonometric part to have a 1 at this point, and then the next term to be 1 over 3 squared plus 1 over 5 squared, etc. So this we let x to be 0, so that this part will give us 1, so that it agrees with this format 1 plus 1 over 3 squared plus 1 over 5 squared, etc. So when you let it to be 0, so we'll have absolute value of 0 equals to pi over 2 minus 4 over pi into, so when you put here 0, so we get to 1, because cosine of 0 is 1. And then when you put 0 here, cos of 0 is still 1, so we have 1 over 3 squared. Put 0 here, we get 1, so over 5 squared. Put 0 here, you get 1 over 7 squared. Next one will be 1 over 9 squared plus other terms. So then you make this one the subject. So we have absolute value of 0 is 0. So 0 equals to pi over 2 minus 4 pi into 1 plus 1 over 3 squared, and then plus 1 over 5 squared, plus 1 over 7 squared, plus 1 over 9 squared, plus other terms. So making this one the subject means 1 plus 1 over 3 squared, plus 1 over 5 squared, plus 1 over 7 squared, plus 1 over 9 squared, plus other terms should give us, so take this one to the left, so will be pi over 2, and then the reciprocal of this one is pi over 4. So therefore we end up with pi squared over 8 as our answer. So this is the required solution for this series. 1 plus 1 over 3 squared, plus 1 over 5 squared, plus 1 over 7 squared, plus 1 over 9 squared, plus other terms. So that is how we solve that problem. Thank you.